All right, so welcome back to the Civil FE exam review. In this video, we're going to be looking at mass moments of inertia. And so in the previous video, we went through kinematics and did some practice there. So if you missed that video, definitely make sure you check it out and work through those practice problems. But in this video, we're going to look at inertia and the mass moment of inertia. So this is more 3D based instead of 2D, where I believe in statics, we did just inertia in general for 2D objects, but this is going to be more for 3D objects. So let's dive right in. All right, so number one says determine the moment of inertia of a solid cone with a radius of 4 meters and a height of 6 meters about its central axis. Use a density of 1,000 kilograms per meter cubed. Okay. Alrighty. Let's see here. So what am I given? It's the information that I'm given. Well, first of all, they give us the radius. It's a solid cone. They give us the height of the cone. And they tell us that it needs to be about its central axis. All right. So we're trying to find, oh, they also give us the density. Okay. What are we trying to find? We're trying to find the moment of inertia. Okay. So hopefully that makes some sense. So are there any formulas that we need for this? So I don't know if you know, but I do not know by heart the moment of inertia of a cone. So I'm going to look up moment of inertia. Let's see if we can scroll through this thing. Hold up. I think we're getting warmer. Okay, so this, see, mass moment of inertia for looks like some 3D objects. Aha, spot a cone. And all right, so I think we've found what we needed. Okay, so, and it said about its central axis, which means it would be along the Z axis, right? Wouldn't be the X or the Y. It's not about its center. The center is coming about this Z axis. So we would be looking at I of ZZ is equal to 3 over 10 MR squared. Okay, so we got one of the formulas that we will need. Okay, so I sub ZZ is equal to 3 over 10 MR squared. Okay. All right. Now the thing is based on the diagram, what is M? Well, M, if we come here, is this, right? Whoa, not all that. Is M is equal to 1/3 pi R, does that say squared or let's zoom in for us. 1/3 pi R squared H times P. Okay. And that P is density. Okay, so let's get M first. So M is equal to 1/3 pi r squared h times b. Okay, m is equal to 1/3 pi. What's r? Well, they gave us r. R is our radius, which is 4 meters. So 4 squared times h. What's our h? Well, it's our height, right? And the diagram will help you if you don't know what this stuff is. See, the r is shown right here. It shows us that it's the radius. H is the height. Okay. So height of this thing is 6 meters. Okay. And then what is P? The density. Okay. And if you didn't know that, density is always equal to mass divided by volume. So tells us in our handbook too, but they already went ahead and gave us density, right? And if you even wanted to go even further, what is mass, right? Mass could be in kilograms, volume could be in meters cubed. And so in our question, we have 1,000 kilograms over meters cubed, which is a mass divided by a volume. So we know that the density unit they gave us is in fact what we need to use. So 1,000 kilograms per meter cubed. And when we solve for all of that, you should get 1,000 or 100 530.06. Okay. All right. After you have solved that and you've got an M, let's plug that into our inertia equation. So I z is equal to 3 divided by 10 times m, which is 100,530.06, and then all multiplied by my r squared, which is 4 meters squared. All right, and for this, I get z is equal to 482, roughly 4.8 kilograms dot meters squared. Okay. So what answer is that? It should be A. Key thing here is to make sure that you have your units correctly, right? These units should have came out, I believe, to be in kilograms. I'm sorry I didn't write that out, but yeah, you got your kilograms, and then you're multiplying it by a 4 meters squared, which will give you the units that you need. So, all right, let's move on to number 2. All right, so this one says, scroll it up a little bit. Number 2 says, calculate the moment of inertia of a hollow cylinder with an outer radius of 6 meters and an inner radius of 4 meters and a height of 8 meters about an axis passing through its center. Assume a density of 1,000 kilograms per meter cubed. All right. So what information did they give us? They give us the outer radius. They give us the inner radius. They also give us the height of the cylinder. Okay. They also give us the density. Okay. What are we trying to find? We're trying to find the moment of inertia of this hollow cylinder. So if you don't know what a hollow cylinder is, you know, we mostly know that cylinders are like this, right? Okay, so a hollow cylinder means there's a hole in there. So this would be considered a hollow cylinder. It just means it has a hole and there's some inner and outer radiuses. Okay. So a little bit of prior knowledge is needed to be able to understand the question. Okay. So now, where do I go in the handbook, or is there formulas that I can use for this? Well, absolutely. So here we have cylinder, like a ring, regular cylinder. Okay, so this would be our hollow cylinder, right? Has that hole. Okay, and one key thing is that it's passing through the center. So that's important. So as far as axes are concerned, you want to make sure that you know what axis they're talking about. So in this case, we would be using, if it's passing through the center, right? It's passing through that y axis. So we want to find the moment of inertia about the y axis, which is here, right? And so we're going to choose should be choosing the IY, which is equal to m times r1 squared plus r2 squared over 2. Okay, so that's our equation. So I sub y sub c is equal to I sub y, which is equal to 1/2. I'm just going ahead and pulling that divided by 2 out. M times r1 squared plus r2 squared. Okay, so what would r1 be considered as, right? Well, that's what our table shows. So the r1 is our outer radius, right? And it points to the outer radius. So r1 in this case, r1 is equal to the 6 meters. R2 go to the 4 meters. Right? Okay, so what is m? That's another unknown that we don't know. M is equal to question mark. So let's get m. So m is equal to pi times r1 squared minus r2 squared times p times h. Okay. So we just break this up until we get everything that we need, right? So it may seem complicated, but it's not. All right. So if you want me to draw a picture too, I can. May help. So we got this. All right. So we know that the height of this thing is what? 8 meters. So I just want you to know what's going on here. From the center to the outer radius is this right here is 6 meters. Okay. And then, which is our R1. And then the next little thing that we would need is the center to this, right? And that value is our R2, which is the inner radius, which is 4 meters. Okay, so hopefully that helps you visually be able to see, okay, here's what's going on. Because you're comparing that to this. Alrighty, so now we need m, all right, m here. So m is a different color. Do dark green. M is equal to pi times r1 squared minus r2 squared, 0 times h. Okay. Pi times 6 squared minus 4 squared. So rho 1000. That's our density, right? Kilograms per meter cubed times the h. What's h? Our height, 8 meters. This is all equal to m. All right, so m turns out to be what? M should equal 502.654.82. Okay. And I believe that's in kilograms, right? This is a mass. Okay, so the last thing we need to do is I think we have all the components that we need for I, the inertia. This is the last variable that we were solving for, all right? And so now it's just a matter of plugging and chugging. So I'm gonna bring all this down. Let's say I y is equal to 1 over 2 times m, which is 502,654.82. Okay, times r1 squared, which is 6 meters squared. Okay, minus r2, 4 meters squared. Okay. There's not minus, it's plus. Apologies. And we should get y should be equal to 1306902.5 roughly kilograms meters squared. And I get my answer to be A. All right, so just taking it step by step, using your manual to go through and solve for this. All right. Three says which theorem describes the relationship between the moment of inertia about an axis parallel to the center of mass axis and the moment of inertia about the center of mass axis. Okay. So it would be the perpendicular axis theorem. I would say no. But what we can do is we can say, okay, what information do they give us? So our axis parallel to the center of mass. So you got you're trying to find a theorem, and they're saying that the axis needs to be parallel about an axis to the between the moment of inertia about an axis parallel to the center of mass axis. So you're given that it's parallel to the center of the mass axis. And the moment of inertia about the center of mass axis. Okay. So basically, parallel seems to be very important. And so perpendicular axis theorem, let's search what that is. See if perpendicular axes. The polar moment of inertia J and area, okay. The moments of inertia of the area about any two perpendicular axes. So the polar moment of inertia. It doesn't mention anything about nothing about perpendicular stuff. Okay, so I would say no. Principal axis theorem. And I just try to search these just to make sure. Principal act. So nothing's coming up there. So I don't know. Parallel axis theorem, I would assume, would be the right answer, but parallel axis theorem. It doesn't really give us too much detail. Okay. Moment of inertia, parallel axis theorem. The moment of inertia of an area about any axis is defined as the moment of inertia of the area about a parallel centroid axis. Okay. Plus a term equal to the area multiplied by the square perpendicular distance from the centroid to the axis in question. Okay, so I'm going to say that's our answer. It's the closest thing. Shape and mass distribution theorem. No, anytime you're wanting to get the moment of inertia and you have two axes in question and those axes are parallel, or axes are parallel, then basically you can't just take its original moment of inertia. You have to get the moment of inertia of the axis, and then you have to add a distance between the two axes in question and multiply it by its area. So your answer is going to be C. So hopefully I did a decent job with explaining that. Just know you're trying to find moment of inertia about an axis and there is a composite shape of some sort, then you're going to have to determine the centroids of those individual composite shapes and compare it to the centroid of the entire shape. And I kind of went through this in, I believe, statics. So if you didn't understand, or if you don't understand what I'm talking about, check out the statics section about centroids. We did a practice problem with the parallel axis theorem. So hopefully this helps. In the next video, we're going to look at force acceleration.